Hello and welcome to this RedMonk conversation. My name is Kate Holterhoff, analyst with RedMonk, and with me today is Carl Sverre, creator of SQLSync and founder of orbitinghail. Carl, thanks so much for joining me today.
Thanks, Kate. Yeah, I'm super excited to be here.
All right, so I invited Carl here after reading a post he wrote titled "Stop Building Databases," in which he lays out what he calls, quote, a front-end optimized database stack. So needless to say, I was very intrigued. But before we start digging into what he means by that, and it's super interesting, Carl, can you share a little bit about your career and technical background, just so folks can get a sense of who you are and your realm of expertise?
Absolutely. Let's see. So about 12-ish years ago, I was working at a company called Mixpanel, which is a user analytics company. And at Mixpanel, I sort of started my entry into the world of data. Like I started to learn about, I was a front-end programmer, so I was building JavaScript applications. But I started to learn about how you could use data to build really amazing client experiences. And so we were taking data, which was user analytics data, and we were rendering into like funnels and segmentation and basically helping people learn about how their users are using their app. But in that process, I got to really love how there was this interesting relationship between this like the server side and the client side. And when you're moving very large volumes of data when you're moving any data, it just made me start to think about that sort of side of thing. So that was where I sort of started this like noodling in my head about this relationship sort of 12-ish years ago. And then I had the opportunity to join a company called SingleStore, which is a database company. It used to be called MemSQL when I joined. And at SingleStore, we were building an analytical and transactional database. So a database optimized for both kinds of workloads. Sometimes people call this type of database an HTAP database or a hybrid transactional analytical database. Or hybrid transactional analytical processing database. But the premise is that you can build really amazing applications when the same system, which is holding your data, can do both sides of the story. And so I learned a lot about databases at SingleStore. I did everything from building sort of our front end stack, our dashboard system, helping people deploy the system. And then when I left, I was doing pretty low level stuff in the database. I added the team I was part of, we added WebAssembly to the database. So we basically added the ability to program the database via compiling sort of from any language that can target WebAssembly, which was sort of an interesting paradigm. And we just tried a lot of really cool things inside of SingleStore. So that was sort of what got me to where I left SingleStore, which was earlier this year in February 2023. And I decided that it was, I was 10 years exactly to the day that I worked at SingleStore. So I had a decade of database experience and I've seen a lot of different things in the data world. And I decided to go back to my roots. I want to go back to front-end programming and I want to approach it from like a little bit of a new angle, which is with all this knowledge about how databases work at a very low level, can we maybe rethink how we manage data in the front end and that relationship between the front end and the server? And so that's sort of my sort of quick TLDR journey.
No, that's awesome. Okay. And, I got to say, I'm always interested in speaking with folks that love databases and data management. So I've met several self-proclaimed data nerds, and I'm just always curious what makes this issue so compelling for them, just, intellectually. So, Carl, have you always been a data nerd, or, what is it about this particular domain that interests you? It excites your your I guess willingness to spend all of your work capital on.
Yeah, that's a really great question. I don't think I've always been a data nerd. If I go back like before Mixpanel, I think I was definitely, I approached computer science less about data and more about visualization. I was really excited about teaching the computer how to make things visually. That was a really big draw for me. Where data came into the picture was really at Mixpanel, where I learned that like when you have interesting data, you can use that data to build data bits. You could essentially combine those two like that data with that passion that I had, which is visualization. And it turns out after a really long time, like after an entire career of data, that visualization in almost any form is a data activity. It really is that if I go back to like the data viz stuff I was doing in university, even though I didn't think of it as like data in the way that we think of data in databases, it is very much like this interesting relationship between data and visualization. So maybe I was a data nerd, but I don't think I identified as such. Sort of a fun, like, round trip that I got to.
I love that because I guess when I tend to think of front-end engineers, you tend to think of them as being in interactive teams with a lot of designers and UX folks. But yeah, there's this whole other side to UI and that's like data visualizations. So when you think about like business intelligence, I mean, that's really their sort of wheelhouse. It's like creating these charts and trying to visualize some of these important concepts. So you're right. You're making me think about this in a different way than I have historically. So one of the things that I thought was really interesting from your piece was this sort of concept, or I guess it's like more of a philosophy of offline first. Could you explain what that means? Because I'm not sure that that's something that everybody's familiar with.
Absolutely. So offline first is the idea that the application is designed to work offline. Okay, so that's the first part of the thing, right? Offline first. So the offline part is the application continues to provide some capability offline. Now, some people might be like, well, you can't have all capabilities offline. Like, what about email? Like, I can't send an email if I don't have a network connection. And sure enough, that's fine. Offline first doesn't mean that all capabilities are offline. It just means that the user can like open the app. They can see the last state that they saw prior to closing the app. They can interact with at least enough of the app that it's useful. It provides some value. That's sort of the offline side. Now, first side says essentially that the way in which the app sort of thinks about data and the relationship between the app and the backend is that it sort of interacts with data offline first. So it interacts with the data on the device first, and then the data is then synchronized sort of asynchronously to the backend. So it changes the relationship between the app and data from the classic relationship, which might be first, we're going to send an API request to the server and wait for the response. That's sort of the very classic strategy. The second strategy might be parallel. So we send an API request to the server, and in parallel, we do some kind of like local optimistic data change. So that would be like where we try to do both things at the same time. And then offline first is we do the operation locally first. We show the result of that operation right away, so the user just gets instant feedback. And then like asynchronously, basically, not in parallel, but asynchronously, we're also telling the server about it. And so the server still gets updated, but we have a sort of like the app experience moves forward locally in a way that is most beneficial to the user. So that's sort of the aspect of offlineness and firstness.
So, my own research at RedMonk, it covers what I've referred to as like the server client two-step, by which I just mean the challenge that's faced by all front-end and full-stack engineers of sort of determining what should be done on the client's browser and what needs to be sent to the server. And but then at the same time, I always joke as someone who's a front end engineer. So, I tend to write a lot of HTML, CSS, a little JavaScript. I didn't really deal with databases when I was a practitioner. And so I'm like super self-aware when I talk about data. And I actually took a Microsoft certification in data fundamentals as part of my research into certifications, because I was like, well, where is it that I need to learn the most? And it's certainly about databases. When I was a practitioner, the backend handled it, just full stop. And yet we're seeing that this is more and more of an important issue for front-end folks to take on. So let's lay out this problem space. How are you thinking about data in terms of the front end, and how are you trying to solve it with SQLSync?
It's a really good question. So I've been thinking about, stepping back to maybe the two-step. Like, I really like that way of saying it. What did you call it? Did you say that the client server?
The client server two-step.
Yeah, I love that. That is a great phrasing. It really captures the spirit of a lot of complexity in front-end engineering. In front-end engineering, as front-end engineers, like, we love creating the visual aspect, like that interaction layer between the application and the user. That's really what I think a lot of front-end engineers would say, at least for myself. I guess I can't speak for everyone, but maybe for you and maybe for me, that we really like that. We like that relationship to the user. And a lot of front-end engineers love the fast iteration cycle as well, right? That like local experience where you change the code and you're immediately seeing the result. That's like pretty sort of tangible. It's very cool. So the two-step is so interesting to me because it's always been the biggest source of friction between me trying to build a really cool experience for a user and the experience actually existing. Is always this like, I spend probably more time thinking about the two-step, that data interaction piece, than maybe sometimes the application itself. Ultimately, like, this is always frustrated me. I don't want us to have this. I want our front end engineers to basically be able to use data very, like, much more naturally, like much more as if it was just another part of that, like, local application model, and leave it up to a different system to figure out how to move data in between the front end and the back end, rather than the front end engineer having to sort of manage that coordination themselves. So that's always been how I've sort of thought about it. When I was at SingleStore, I was doing this WebAssembly work. So for anyone who's watching, maybe they aren't familiar with WebAssembly. WebAssembly is basically you could think of it as, there's a lot of ways to think about it. Let's say that it is a general purpose way of representing logic or like computation. Right? So we have code. We all know code. We can sometimes compile code into other representations of that code, and then that compiled code can run on different machines. We can sort of think about this relationship between code and computers. We can think of WebAssembly as another kind of computer that we can compile to. So we can run basically different kinds of code on this like WebAssembly computer. And the best thing about WebAssembly, and maybe the name sort of hints at it, is the ability for WebAssembly to run inside the browser, as well as on the server side. And so we have this flexible computing abstraction where if we compile code to this virtual computer, this WebAssembly computer, we can run the exact same code on multiple places, like in the web browser, with like right beside JavaScript, and also in the server. Now, why do I bring this up? Because when I was at SingleStore, I got really into this concept of moving compute to data rather than moving data to compute. And so when we think about databases, generally, like in a backend system, we'll have some kind of centralized database. We'll have Postgres, we'll have MySQL, something, a very standard database, and we'll have our app. And like usually we think of them as like two different entities. When the app wants to do some processing on data, it will send a query over to the database. The database will process the query and return the results to the app. So you'll get back rows or query results to the application. And then the application will do additional computation. It might run multiple queries, might do different things. Now, this relationship is interesting because we could also consider a different option, which is instead of having this app over here and this database over here, what if we just take the app and we put it inside of the database? So suddenly we've eliminated this like round trip between the application and the database to be able to process that data. We've essentially moved compute to data. So why am I bringing this up? Because this is a similar two-step that we do with front-end engineering. With front-end engineering, we have our front-end on the left side, or my left side, maybe your right side. I don't know. Weird. Okay, so we have front-end on one side. We have the back-end on the other. And the two-step is basically you're doing some compute over here. You're doing some compute over here. You have some data over here. You have some data over here. And you're trying to figure out how to coordinate those two sides of the same coin. This is a hard problem, like a really hard problem. And at SingleStore, I started to experiment, as I said, with putting the app inside of the database. What if we compile the app to WebAssembly? We take advantage of the fact that we now have this sort of abstract version of our app that we can run sort of anywhere, and we copy that application directly into the database. So now, instead of having this two-step, we just have a one-step. We're just in the database. We run the app with the data. We're doing super high frequency, low latency operations back and forth. Maybe it's a simpler paradigm. Maybe you no longer have to worry about moving stuff around. So when I left SingleStore, what did I do? I said, can we do that? Can we do that sort of interesting relationship? Can we change the relationship between our app and the database? Can we do that with the front end? Can we change the relationship between the front end and the back end? And so in SQLSync, which is a database that I've created, under the hood, SQLSync uses SQLite, which is a very sort of foundational database. It's a super mature database, been around for a really long time, very robust. I take SQLite and I wrap SQLite with, you can think of as essentially the API layer of your application. And that API layer is compiled to WebAssembly, which means I can run it both in the client and like beside the JavaScript. And I can also run that same API layer on the server. And so now what I can do is if I figure out how to move data from the server, like the underlying database from the server to the client, I can now run that API locally in the client. And I can eliminate things like network latency, complex caching, complex optimizations, complex query execution. Imagine, you're building a table view in your front end application, and probably most front end engineers have done something like this. They have some table view. What do you call it? Like project manager? No, not product manager. I was like, too many P's. Okay. So the product manager says, hey, front end engineer, can you sort this column, please? Like if the user clicks on the column, like sort it. This sucks. Like usually it means you're going to send like a new API request to the server. You're going to resort the data. It's going to come back. You have to refresh, reload the data in your data view. With SQLSync as an example, because we can move that API layer, no matter how complex that API layer, we can move it from the back end to the front end. When you want to resort the data, you just issue a local API call. You say, give me the data in a different sort order. SQLSync manages understanding what data is like local, and it can immediately resort that information without you having to do anything different. The same exact code that knows those custom sort systems. Because like sorting is not always the simplest thing. It doesn't necessarily mean you just, alphabetically sort. You might have to sort using a custom comparison function. You might have some complex code. Maybe you have some more interesting query that you're running locally. So all of this is to say, why did I build SQLSync? Because I believe that this two-step is very annoying, and I'd like to be able to solve this by moving that back-end system into the front end and then intelligently dealing with knowing when we're going to run that front-end code, when we're going to run the back-end code, and eliminating the need for the front-end engineer to think about it.
Okay, so I think I have a bit more of a handle on why we should, quote, stop building databases and instead build a front-end optimized database stack here. And SQL Sync is the way to do this, right? So I'm interested in your argument that there is a mismatch in the data model for the client and the data model for the server. So the implication is that there's some sort of transformation which creates that disconnect. Is there a precedent for offline first in industry that has been, able to successfully bypass the issues that come from being, I guess, the opposite of offline first would be online first. So is there a way to not, this is already happening, that we've seen this work in the past?
I think that's a very interesting question. So maybe there's two questions there. So one question is, of course, like who's in the industry is maybe enabling some of these things. And then the other part of the question is sort of like offline first as perhaps a forcing function. Offline first as perhaps a different way of representing a data model, and like what that means. So we'll start with the first one, which is industry that have sort of adopted different ways of building apps that maybe have benefits over the classic application architecture. Some of these are really old school apps that everyone will know. So I'll say two of them, which is email and calendar clients. Like basically every email and calendar client on the planet, it's probably not true. Many of the ones that you would use, so like the Gmail client, many people have used that. Outlook, which is a desktop application that you can use. It's now a web app, but it basically has the same concept. These systems are, they're actually like, I would argue, like offline first. They're designed to do most of their operations on an offline version of the data. And they continually are sort of synchronizing that offline version of the data with the online version. So they're talking to the server to be able to say, hey, do you have any new emails? Okay, great. You have some new emails. Let's bring it down to our offline version. But when you open up Outlook, for example, in like Microsoft Windows, you open up your Outlook email client. It doesn't matter if you have internet or not. Like it's going to show you the last view you saw before you closed Outlook. Whether that is an email, whether that is an inbox, you're going to see that. And then it's going to asynchronously sort of update itself if there's internet as fast as it can, but in a very sort of asynchronous way. And we're used to using these types of apps. These apps work really remarkably well, and they add a lot of reliability to the system. Similarly, you send an email, it goes in your outbox, right? It doesn't right away go to the destination. It's queued for send, and as soon as it has internet, it's going to send. Some more modern apps that are approaching this problem space have learned, and this is where the offline first data model becomes really interesting, have learned that they can actually build collaborative experiences by adopting a offline first data model. So in their email and calendar apps, it's a single user system, like only generally, one of us is interacting with the system. So there's no need for real-time collaboration. But if you look at, for example, like Figma, if you're familiar with the design tool named Figma, or Linear, which is a task management tool, both of these applications have adopted a offline first data model where the data is designed to the data is designed to synchronize from the server to the client. And then the client can actually take operations directly on that local data, that local version of the data. And then those operations can be synchronized asynchronously, which is an important piece of this architecture, with the server when there's internet. And you can sort of think of this as like how email works. Like to a certain extent, the way in which like Linear works can sort of be thought of as how email works. On the client, we have like some data that we've cached locally, which is sort of like our emails that we've cached locally. We have an outbox of things that we want to do, like essentially in the Linear model, maybe you're trying to add a task to the system, you're trying to do whatever. And we have we've separated the application concept from the like network concept. The network can happen asynchronously and the application continued to work. So we're starting to see this trend towards collaboration as sort of like a first-class citizen. And interestingly, if you look at like a lot of ways in which people are building collaboration, they are building it in a way that is also offline first. In one of the talks I gave earlier this year at QCon New York City, I mentioned this concept that like offline first is a forcing function. And what I meant by that is that by building your data model, the relationship between your application and the data, by building it in a way that supports offline first, so you could sort of vaguely think of it like by building your data model similar to how we think about email and how email clients work. And that is a very like abstraction on the topic. The topic is much more complex than this, but I just wanted to give you a good metaphor, which is like emails. We can all think about how emails work. By building a data model that is sort of similar to that, we can gain collaboration because collaboration it's important to be able to work as fast as users work. Collaboration is frustrating and is slow when every single operation you execute has to be synchronously committed to the server and back, i.e. there's like an API request in the collaboration loop. When you're editing a Figma file, it would be really frustrating if you like moved an object for that entire move operation to like wait on asynchronous requests and response to the server, right? Like building a model where we can actually do that move operation entirely locally with no network connection at all allows us to have super low latency on our operations and thus build a more sort of like real-time experience. And then collaboration is enabled by essentially building the collaboration part, like the way of merging data. By building that directly into the data model, we can gain that collaboration. So this is a little bit of a wide topic that I'm trying to address here, but going back to sort of the question, which is like, is the industry adopting it? I think absolutely yes. And going back to the question of sort of what about offline first helps the system? It's sort of by thinking about offline first, even if offline first isn't necessarily a product feature that you're trying to enable, by just simply making that part of your design space, you can more simply build a collaborative app that gives you that real-time experience.
Right. And I love that idea of the Figma file just moving one pixel at a time as it pings the server for every little movement. So yeah, I think that really helps me to envision how it's already working. And yeah, I mean, this is the sort of obvious solution, but it is a sort of mental disconnect of like, in order to collaborate better, I need to go offline. Like that's just, it takes it takes a sort of adjustment in how we think about this, but you're absolutely right. I mean, it's almost like that, you need a little time to I guess, be quiet with the work that you're doing. And then you can collaborate better because we actually have something that's a little more finished before we, dig into it as a team and actually try to get this project accomplished. Right.
That's another aspect of it as well. Yeah. There is some other interesting aspects of offline first, which I think you're highlighting, which is that by building this data model, you also gain the ability to choose to go fully offline, to work offline as a feature. And this feature, like when you're writing a doc, I've seen a couple of interesting startups. Off the top of my head, I can't remember their names, but there's been a couple of startups recently that have started to experiment with like different ways of doing sort of document collaboration. where rather than the Google Doc style where everything is online all the time, where like you always see the user's changes all the time, switching to a model where it's more like, okay, I'm going to check out this document into sort of my own version. I'm going to edit that version. No one can see those changes. And then when I'm ready, I'm going to like merge back in. So maybe more of like a Git style, like source control management style sort of document workflow. And that's also an offline first workload. Like even just Git as a version control system is an offline first system. We have the database, which is designed to run entirely on the client. We can run operations locally on the client, and we can synchronize asynchronously. So yeah, offline first is everywhere. It's just being able to use it effectively is the hard part.
Yeah. I love that example because I got to admit, anytime I'm on a Google Doc writing with other people, I'm just sitting there reading what they're writing. And, it's I could definitely be getting more done if I wasn't spying on my coworkers. Okay. So it seems like SQLSync fits into this sort of larger conversation that's going on in the front end development space that includes sort of caching, hydration, and state. So a number of front-end frameworks are coming up with innovative solutions to these problems. So I'm thinking of like with the React server components and Islands architecture, which is used by frameworks like Astro and Fresh. So I guess I'm just curious, why are these solutions not sufficient? And if they do have a place, where is SQLSync a better solution?
It's a really good question. So when we're talking about front-end applications, we can think about them as maybe from a couple different perspectives. So the first perspective is front-end apps, especially like web apps specifically, where React server components and islands are predominantly being used. Web apps have this interesting distribution model where you go to a URL and you've effectively downloaded the app. There's a different distribution model to like how we distribute native applications. Native applications, you go to maybe the app store, you click install, it's installing the app, like you have this clear concept of like, I'm getting a thing on my computer. And then you then open the app and then you can use it. It has its own internal sort of navigation system. The web is interesting. We've correlated the like navigation system with the distribution system. And that is one of the key innovations of the web that's made the web grow so quickly. Okay, so why do I bring this up? Because React server components and islands are directly sort of related to this new paradigm of a distribution system. With this new distribution system, we need to be able to essentially load an application from zero. There's nothing on the user's device to a working app as fast as possible. We want, when a user goes to a URL, we don't want them to have to wait for the entire application to install all at once, right? So a lot of these features that have shown up in the web platform are really tightly coupled to that like web distribution architecture. This idea that we can sort of go to any app at any point, whether or not the device has ever seen the app before. And because of that, being able to do sort of some server-side rendering, like React server components, being able to sort of pre-initialize some of the state that they're going to need to be able to render that application, that's a form of caching. It's a form of accelerating that time to sort of first byte for that user. And these are great ideas, and these ideas don't necessarily go away if you adopt a offline first data model. You can actually have both. And so this is sort of like, I think, a good way to think about it. It's like, well, why do we need these things? Well, because we want to be able to do incremental rendering. We want to be able to accelerate that time to first byte. We want that user experience really good. That's one reason. Another reason is that some frameworks have started to adopt this idea that we can do sort of like partial server-side page re-rendering, where you click on like a button and we're going to essentially just use like an island, for example, to just update like a portion of the page to a new content. And different frameworks do this in different ways. Some frameworks will actually send down like HTML fragments that were rendered on the server that can be like loaded via JavaScript into that component inside the server, and that's where you get, or inside the client, that's where you get things like islands, which is interesting. And then other frameworks will work really tightly with like the React layer, for example, or other front-end framework layer to turn those, like when I click a button, turn that into an API request that would maybe retrieve some JSON, and then that JSON will end up being processed by the client and then hydrating into like a new client component state. Okay, so that's all sort of just preliminary, getting up to the point where like I have an app. I have an application that's like running in my client. Those tools that we have, like React server components and islands, are important mechanisms to incrementally turn a blank page into a working application. And they're very important. But at some point, if you're building a rich client experience, you're building an experience where the application is doing is a rich experience. So what is a rich client experience? A rich client experience is Figma and Linear and Airtable and Google Sheets and Google Docs. These are experiences where you want low latency interactions with the data, essentially. If you had to do long asynchronous server request responses for data operation, the application would be less nice to use, not as good, right? So this is how I define in my mind like this rich client experience where you want to be able to do low latency interactions. And how do you do low latency interactions? In order to do low latency interactions, you predominantly have to adopt a concept called optimistic mutations. So you have to be able to essentially optimistically change the data that is locally cached to be able to bypass waiting for latency. So you have to basically say, I'm pretty sure I know what's going to happen when the user clicks this button. And so what I want to do is optimistically just do that thing that I think is going to happen on the client before the server gets back to me. And if we can do this really well, suddenly we have a rich client experience. We have a client experience that feels maybe more like a native application where the user is using data on their device. This is really, really hard. It's hard to build optimistic mutations. And I wrote a whole blog post about why it's hard and all of the things that you have to now consider once you start to build optimistic mutations. And I'll say one key thing that's pretty easy to rationalize why this is difficult. An optimistic mutation requires basically reproducing API logic that exists on the server in the client. Like if we want to be able to do something optimistically, we have to be able to predict the outcome of that optimistic thing. How do we do that? Well, we have to reproduce the logic that produces that output, which traditionally sits on the server. We have to reproduce that logic in the client. Software engineers don't like to repeat ourselves. We like to keep things simple. But the idea of reproducing API logic on the back end in the front end sort of defeats that. It makes our apps more complex, makes them more fragile. If they become out of sync, suddenly you have this problem where, oh my gosh, we show the user one optimistic result, but then the server just writes all over that with some different outcome, right? And that's a bad experience for the user. So all of this is to say that React Server Components, Island, these are great solutions to incrementally streaming that initial experience, to creating a relationship between the server and the client that is a little bit more sophisticated, that allows us to do essentially less work to get more benefit, right? We only need to stream down a subset of the application visual model to be able to update state. That's all great stuff. But when we want to add rich client features to our app, when we want to have that ultra low latency sort of relationship with the user, we have to have a system that builds around the idea of optimistic mutation, the idea around local queries where we can reshape data quickly without waiting for the API response. When we start doing that, we add complexity to the system, and ultimately we end up with these very complex rich client applications. So why did I build SQLSync? Because I wanted to build a database that runs inside the browser. And I wanted to be able to build an API layer that I can run both in the backend, like a traditional API. And I can also copy that entire API down to the client to be able to run optimistic mutations directly inside the client application, such that the developer no longer needs to think about copying and reproducing logic. SQLSync is able to run the exact same API running in the server. It's able to run it locally. It's able to manage the data relationship. It's able to track query subscription. So it knows which portion of your app is based on which portion of the data. And it's able to do that without the developer having to think about anything. That's sort of the approach that I want to start to lean towards. SQLSync is currently well suited for, I think of it as two kinds of applications. It hopefully in the future it'll be suited for a lot more apps, but right now it's really designed well for these two concepts. So the first concept is sort of what I call user-oriented data models. So a really simple example, we've been using the metaphor of email, and email is like a user-oriented data model. It's designed pretty much for one user. We want to have cross-device synchronization. We want all of the users' devices to sort of see the same state. So that's a nice aspect of the user-oriented data model. And we're predominantly working with sort of the data of one user. The nice thing about the data of one user is that the data of one user is relatively small, and we want to synchronize it to every single one of that user's devices. We want to have that cohesive experience. Another kind of application that's really good within that same category, the user-oriented data model, would be like a personal knowledge management app. So think about apps like Obsidian, which is like a personal knowledge base. Personal wikis, for example, are also good. Personal task managers, or even like personal financial sort of solutions where, it's about one user's data. So even like a banking app, having SQLSync manage the local side of your data. Now it's not going to be able to run financial transactions for you, but it can at least show you your accounts, show you all your transaction history. You can provide a really nice local low latency experience over analyzing that data, which is really ideal because it's a single user data. So any kind of app that's really optimized around sort of single user data can really effectively use SQLSync. The second kind of app is what I call like document-oriented data. Document-oriented data, you can think of as like Google Docs, Google Sheets, Figma, Photoshop, Airtable. When you're using these apps, you're basically working with a single sort of document. In Google Docs, it's literally like a text document. But in Figma, it's a design document. It's some kind of like image that you're collaborating on with other people. In the case of like Airtable, it's a table. Right? So these apps have a documented oriented model. When a user has opened a document, they only care about that document. So you can think of as like browser tabs. Like each browser tab might only care about a single document. And we want to be able to optimize for like low latency interactions with that one document. And so SQLSync works really well for document oriented models as well as like per user data models. The other kinds of data models you might sort of say, okay, what is that compared to? A really common data model in a lot of web apps is like multi-user collaboration models, where the size of data is larger than what you can put on a device. So a really easy example of that is something like Jira. Jira, which is a huge enterprise task management solution, if you went to most enterprise companies, the amount of tasks inside of their Jira instance is probably more data than you'd want to put on every single device. Like you don't want to have that huge data set completely offline first. And because you don't want to do it, you have to build this really interesting system where only a very small subset is on each device. And that does work. People have built it. Linear is a good example of a task management tool, which has this offline first thing where they figure out what is the set of data that the user has sort of cached, and we can do local operations on that data. The downside of this approach is that you're not completely offline first. You're not able to look at all of the data. You're only able to look at the data that your device happens to have cached the last time it communicated with the server. And so it's a different kind of data model, and it's different kinds of sort of data scale. But ultimately, SQLSync is really well optimized for document-oriented data models and user-oriented data models.
All right. I think that summary is an excellent point for us to wrap up. So I especially want to thank you for coming on here today, and even using my country line dance metaphor with the client server two-step, warms my heart. So before we go, would you tell folks how they can hear more from you, Carl? What are your preferred social channels? Are you planning on speaking at any events in 2024? How can we keep up on SQLSync?
Absolutely. So SQLSync, you can learn more about SQLSync on SQLSync.dev, which is the main website for SQLSync. There you're going to be able to see the blog post I wrote, which talks about a lot of these concepts. And then I'll be able to release more content there and hopefully start to build a community around this idea that we can make simpler apps by building around offline first and building around a front-end optimized database stack. So that's SQLSync.dev. You can also, for me personally, you can follow me on carlsverre.com. So my just full name.com. There I have all my social channels. I have my own personal blog, which is just starting. I'm hoping to do more, but that's the big thing. And then as another point is I am planning on attending conferences in 2024. And if you want to sort of meet me in person, some conferences that I recommend checking out is Handmade Seattle, which I'm not sure when it's going to be yet, but that's a really cool conference. Software You Can Love, which might be in Italy, which would be really interesting. QCon and WasmCon.
I want to thank Carl for chatting with me about his open source SQLSync project and weighing in on the front-end data management issue. So my name is Kate Holterhoff, analyst with RedMonk. If you enjoyed this conversation, please like, subscribe, and review the Monkcast on your podcast platform of choice. If you are watching us on YouTube, please like, subscribe, and engage with us in the comments. And with that, thank you.